Swayam Prabha. Digital India. Educated India.
Now I am going to discuss another aspect of compaction of soil, and this is actually I have discussed in my previous lecture, all two lectures about shallow densification by roller and similar type of equipment. And now I have mentioned that that roller compaction main disadvantage or disadvantage is that we cannot compact in a in depth, because there is a limitation, and when there is a large area to be compacted, that may be by roller and some similar equipment may be difficult. In that case, sometimes we use another compaction technique. There are several, but I will discuss another only one, that is deep dynamic compaction. And what it is, let me show you first. So, this is the typical deep dynamic compaction equipment. There will be a crane, and this through this crane there will be weight will be lifted at a sufficient height. What will be the height, etc., some calculation will show later on. This based on similar height will be lifted, and this weight will be finally released freely on the ground surface. So, it falls here, and you can see this marks is that is this depression, that means some soil will be that significant subsidence will be observed on the soil. So, when there is a subsidence, that means what will happen? Soil grains will be pushed, and then they may come closer, and it will result the compaction effect. So, that is the technique generally used in deep dynamic compaction. So, what is dynamic densification? Dynamic densification is when the dynamic compaction is used on unsaturated granular geomaterial. The impact by heavy tamper immediately displaces particles to a denser state, compresses or expels air out of voids, and reduces the volume of voids. So, that is the purpose. Compaction main purpose is removal of voids or reduction of void ratio. So, that is what this is the way it is working. Now, you can see your deep dynamic compaction is generally not recommended for clayey soils with high plasticity index and high degree of saturation, because if it is a soft soil, heavy weight falls on it, it will just displace, it will not compress. If suppose this much compression happens, a similar amount of here actually it will displace upward. So, there will not be any if it is soft, because of soft. When it is a little stronger soil, and because of this effect, then this grain will be pushed and come closer and get densified. So, this is the one that clay soil with high plasticity and high degree of saturation, this is ineffective. Drainage and dewatering are required to reduce excess pore water pressure in clayey soil generated by deep dynamic compaction if used for such soil. So, suppose a clayey soil is used, so if you can put some sort of drainage arrangement, and if you put load here, sometime during the this heavy pressure, the excess pore pressure will develop, and until unless this excess pore pressure is dissipated, then the volume reduction is not possible. Then when the excess pore pressure through this path, the water actually will go through in this drain, and then pore pressure will be released, and because of this release of this pore pressure, then the subsidence will occur. So, that is the thing, the additional requirement. If that is not suitable, but if at all if we use, then what you have to do, you have to provide additional dewatering or drainage. That means this drainage, and then finally water to be taken out, then only it is possible. And high water table reduces the effectiveness of dynamic compaction. Water table, if it is there, this is not going to work properly. Then application, the use to improve problematic geomaterials by increasing bearing capacity. So that is the purpose for always improvement of the bearing capacity. First thing to be improved, reducing settlement, that is second thing, minimizing collapsible potential and mitigating liquefaction potential for commercial and residential buildings. So if there is a loose fine soil and there, and then water table comes, and then during earthquake liquefaction may occur. So because of that, beforehand we need to densify them. So how to do that? We can do dynamic compaction even quite great depth. So these are the various areas: storage tank, highways, railways, airport and harbors. These areas, if you have weak soil, problematic soil, then we have to improve it by some means. And if you want to improve up to a greater depth, this is the perhaps the good choice for improvement. And it has several advantages, as I have also mentioned, that improve a large area of geomaterial in a relatively short time at low cost. So it will be a crane which is having some arrangement. It can move around quite fast, and in the desired location it will go and lift the weight and drop it, and like that very quickly it can be covered a large area. So that's what it is, relatively short time at a low cost, and effective for loose and partially saturated fill with less than 15% fine. So fine content is more, then it is not good. That's what can detect weak or loose areas during operation. When there is a weight falls on the ground, and if it sink too much, then automatically we will get some information, additional information, that there below there is some weaknesses. Similarly, can change a heterogeneous material to a more uniform, denser and stronger material. So by several drops and with predetermined location, we can compact uniformly. And major equipment needed for this method is a crane and a tamper, which are readily available. So because these are the, so crane is available, and tamper actually you can make it. It can be of steel, it can be of concrete. So anytime it can make a weight. So these are actually very simple equipment. So these are the advantages. And now there are some disadvantages, obviously, and disadvantages are generally less to more effective in improvement saturated clay soil. So when it is saturated soil, it is generally not. Sometimes if you use, it is less effective. So that is our most disadvantage for this method. Drainage and dewatering and long waiting period is required used for saturated. When saturated soil, I have mentioned that there is a provision of drain and all dewatering you can use, and then you can apply. But for dissipation of pore water pressure and subsequent subsidence, it takes some time. So waiting period will be there. So that is also a disadvantage. And another most important disadvantage, induced noise and vibration and lateral movement, which may cause problems to nearby buildings, structure and utility lines, and also neighboring people. Sometimes if you do this type of operation, entire locality will be vibrating and people may complain. So that is another most disadvantage for this method. And another is not that big but minor, that mobilization cost may be high when large crane and tamper are used. So when it is a compaction up to a great depth is required, then we have to take a huge crane and maybe huge loading, and for which if it is a proper access is not there, maybe that mobilization cost will be a significant amount. And also required instrumentation to monitor various aspects. That means instrumentation obviously required. And also another disadvantage which is not mentioned here, that entire improvement work cannot be done by deep dynamic compaction, because when you do deep dynamic compaction, that it is improved at a greater depth, but a surface soil will be highly disturbed. Suppose this is the one, because of dropping of weights, surface will be very irregular, and this thickness sometimes 0.5 meter to 1 meter actually disturb depth. So, in conjunction with this deep dynamic compaction, you have to use roller to finally get the finished surface. So, that is another disadvantage of this method, because deep dynamic method alone is not sufficient to improve the surface site. Then design consideration, what are the aspects you have to look at when you go for a design? Before the design, deep compaction is geotechnical investigation required to evaluate site condition, which include. That means we know for which soil this method is applicable, which soil it is not applicable. So, geotechnical investigation you have to do, and then you have to first characterize the material, and at the same time we have mentioned that if the water table is at a higher depth, that time also it is not that effective. So, that also to be seen. And geotechnical properties profile include geometrical type, particle size, fine content, degree of saturation, and Atterberg limit. This has to be essential part to be seen. Relative density of cohesionless geometrical. So, relative density, if it is what level it is there, then only you can design how much to be densified. If it is at relative density at site is nearly 80%, hardly any densification is required, and if the relative density at the site is on 30 or 40%, then you need significant compaction. Then groundwater table, as I mentioned, possible voids, if there is any unseen voids below, then possible presence of hard lenses within the depth of improvement. That means if there is somewhere soil almost uniform, suddenly there is a thin layer of hard rock or something, that to be investigated before doing this. Otherwise, below that it will not be effect will not reach. Then possible sensitive soil. So, if there is a sensitive soil, that to be also. So, by geotechnical investigation, these are the things first has to be identified. And then influencing factors. What are the factors it can affect the compaction? So, these are the things I mentioned. You can see influence factor includes geometrical type. That means if it is a soft soil, not good, granular soil is good. So, geometrical type is the one point. Depth and area of improvement. So, how much depth is required? If it is required within 1 meter or so, then we need not go to this, because we can do a 2-3 lip thickness and you can do by roller. But when you require a great depth like 10 meter, 8 meter, then sometimes it is not good. And also if the area is very large, then roller is not good, this will be good. So, this is the depth and area improvement, that is another influencing parameter. Temper, geometry and weight. So, if you use smaller weight, small effect. If you use bigger weight, bigger effect. Again, if you bigger weight but smaller contact area, you will have something, and bigger weight also bigger contact area, there are also some effect. So, those things also influence the compaction efficiency. Drop height and energy. So, drop height obviously relate to energy. More the height, more will be the energy, and height and weight, these two together actually give you the energy. So, that is actually to be sometime influence the compaction efficiency. Then pattern and spacing of groups, so drops actually. So, how we will place what distance? Sometime you are doing like this, then doing this. Instead of that, or you are doing this, and some are doing in between this, like this. So, there are different ways we can place the load, and accordingly your effectiveness will change. Depth of crater, then how much is going, number of drops and passes. So, how many drops you are giving, that depends on that. Actually, your effectiveness of compaction will also there. And degree of improvement and induced settlement, how much settlement you can permit. The environmental impact, that means if you use a particular weight and particular height, we can find out what is the vibration level, peak particle velocity, and if there is a nearby locality, there is a limit for peak particle velocity, and so you can calculate that, and we can finally decide what weight to be used and recommend. And presence of soft layer, hard layer, high groundwater table presence, etc., these are of all actually influence the compaction. Now, I have qualitatively mentioned that some soil is good, some soil is not good. This figure actually shows the range where actually it is good. You can see so pervious soil, plasticity index 0, permeability greater than this, and zone 2 semi impervious soil, permeability is this. This is the range, and this is the zone 3 PI greater than so. This is the zone actually where actually you have good for deep dynamic compaction. Now, depth and area of improvement. You can see now how much depth to be improved. That I have mentioned that it is related to energy, and energy again related to weight of drop and height of drop. So, that depth of improvement depends on project requirements for desired performance. For example, a loose and saturated sand layer susceptible to liquefaction should be improved to the depth below which no liquefaction will occur. So, that means up to what depth you have to improve, that actually based on geotechnical investigation we will get. Suppose if we get at 5 meter depth and we get a loose saturated sand, and that thickness may be another 5 or 6 meter, that means from 5 meter to 10 to 11 meter that soil has to be improved. So, that is the requirement, and that if that is a requirement, this method can be used. And so, to use this method, and as know how much depth it will reach the effect, when you use a particular weight, how much depth it effect will reach, that calculation can be done. So, that depth of improvement will be NC under root NC into under root WT into HD. So, DI is the depth of improvement in meter, and how much meter is going, weight of tamper in ton, HD is the height of drop, that is also in meter, and NC is the constant. So, if I know this, then I can find out how much depth it will go. Accordingly, I can adjust this height and weight, so to reach a desired depth. And sand up to 10 meter can be improved by this dynamic compaction, where cohesive soil and clay fill can go only up to 5 meters. So, these are the limitations by this method. And that NC value is given, constant NC value, and you can see that different types of pervious soil, if you deposit granular soil, and degree of saturation is high and low, two category it can be there. Then NC to be used for 0.5, and here actually 0.5 to 0.6. So, pervious soil deposits, that is granular soil, high to low, high degree of saturation, low degree of saturation. If it is high, 0.5, is low, it is 0.5 to 0.6. Similarly, semi pervious deposit, primary silt with Pi less than 8, and then it will be high saturated saturation, low saturation, then high, if it is high saturation 0.35 to 0.4 and low saturation 0.4 to 0.5. Semi pervious deposit, primary clayey soils with Pi greater than 8. In that case, you have again high degree of saturation and low, in that case not available, and this low then is 0.3 to 0.4. So, so these are the value NC value can be taken for calculating and to decide whether the depth of improvement is suitable for the particular weight and height. If it is not, we can change the weight and height. to adjust the requirement. Now, tamper geometry and weight. Here also different geometry is possible, made of steel or steel infilled with sand or concrete. There is another type of material can be made. Fully steel possible, steel shell, there will be shell of steel and inside sand or concrete will be there. Circular or square base with area 3 square meter or more. Then tamper with smaller base area are commonly used for granular soil. Large areas are used for cohesive soil, because otherwise more contact will displace. And weight typically 5 to 40 tons. So, this is the weight, tamper weight is 5 to 40 tons. So, you have to choose in between, and height also adjust to adjust the requirement. Also, while choosing height and weight, you have to see that what peak particle velocity it is giving, and that also is one of the controlling factor, because if you adopt that and it gives you lot of vibration, there will be complaint and then work will be stopped finally. And how we can actually compact actually? This is the arrangement actually. This is this is the 1 level. This is 1 and this is 1 2 is written. So, that means if I have a geometry something like this, so I can do here, I can do here, I can do here, I can do here, do here, do here, like this I am doing. And then this is if I do, that is marked as 1 and then I do here, 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 these are marked as 1 2. That is the first level of compaction, phase 1 and phase 2. So, that means I have done here, done here, done here, done here, done here, done here. This is marked as 1 1. You can see over here 1 1. This is another 1 1. This is another 1 1. Then another 1 1. And next level, in 1 2 level, we are putting these. So, that means entire area now covered. So, that is phase 1, phase 1 1 and phase 1 2. So, after covering this entire area, still you might have not achieved the required compaction. Then everywhere now second phase we are putting drop everywhere. So, that is written as 2. So, that is the plan, different ways one can plan. So, that is the way when it drops here, its effect will go this to this, this to this, and when you put this one, effect is going this to this, and when you put here, it is going this to this. Like that, the area is there is overlapping, so compaction is going on. And then when you go to the higher layer, again it will compact, that overlapping will become closer. So, this way your compaction will be achieved. So, there will be different pattern one can use according to the requirement. And as I have mentioned that it is typically a picture shown from the side. This is a crane and the weight is dropped from here, and because of that surface you can see highly disturbed, the other places disturbed. And as I have mentioned that deep dynamic compaction alone sometimes cannot do the complete job, and it is seen that you can see this area already, suppose deep dynamics compaction is done and its surface is somewhat leveled by something, and then finally there is a roller is running here to final finishing of the work. So, that is the small disadvantage for this, but advantage is more, because I am putting a weight here, but its effects is going, it is more than 10 meter depth. So, that is the very effective way to compact the soil. And these are the few things. You can see that induced settlement. So, how much is permitted? So, natural clays 1 to 3%, and clay fields 3 to 5%, natural sand 3 to 10%, granular fields 5 to 15%, uncontrolled fields 5 to 20%. So these mass actually induce when you do the compaction, the how much settlement takes place. This is the in percent of the depth. If it is compaction is done 3 meter or 3% of 3 meter, that means surface settlement we are expecting. Or suppose if you do here 10%, so if it is 3 meter, 10% of 3 meter, 30 centimeter compaction will get here. Similarly, as I have mentioned, another governing parameter is the peak particle velocity. That means in a site, if you do the compaction, and during that compaction lot of vibration will be there. Vibration will be measure of peak particle velocity that will propagate, and because of that some method is there. I am not discussing that, not important at this level perhaps. So peak particle velocity can be calculated based on weight, height and soil type, and that calculation if you do, and there is a limiting value. So limiting values are given here actually. As commercial and industrial, the peak particle velocity permitted 20 to 40 millimeter per second, where a residential building 5 to 15 and sensitive building 3 to 5. So you have to calculate and see that those values well below this, and then only you can go for it. So with this actually various aspect of compaction I have just completed, and like shallow compaction, deep compaction, there are many other compaction methods, bed vibration, there is a vibrophotation, and there are many other compaction like soil improvement. There are many other methods like grouting. Then there may be dewatering also, that is another method to improve the soil. So ground improve when soil site actually not suitable for construction, you have to improve it. And if there are different ways that soil can be improved, and what I have discussed is the densification aspect. That means if the soil is loose, and if the loose is the shallow depth, then we can do by roller and all, and if it is up to a significant depth, then we can use densified. But other method of improvement, ground improvement, we are not discussing here because it is not the right place, because those type of ground modification for improving the site will be the major aspect of ground soil foundation engineering part, or sometimes site investigation, ground improvement, there may be separate courses. So those areas with detail can be learned, but whatever undergraduate level compaction related things, I think I have covered more than that. So I hope that will be useful for you. Thank you.